So we're picking up with our lab here. We've just gone through our 2960 and we've verified that Spanning Tree is actually running. I've got the trunk links all set up and we've determined which switch is the root bridge. It's this guy right here off Gigabit Ethernet 04. So which switch is that? Well, let's think about the rules for Spanning Tree. Again, the bridge ID is a component of the priority plus the MAC address. And you'll recall that since MAC addresses are generally assigned sequentially, that the root bridge will probably be the oldest switch on the network. So, given that, we can probably determine that this 2900 is the root bridge. Let's verify this on our 2960, and we'll verify the same thing over on the 2950. So the 2960 tells us that the root bridge is off port 52, Gigabit Ethernet 04. We simply do show CDP neighbor, and Gigabit Ethernet 04 is indeed pointing at the breakout switch. It's a 2924. If you look over at the 2950, it's timed out. I've taken so long. If we do show Spanning Tree, it also says that the root ID is this CF40, the same as the 2960 over here. We scroll up a little bit. Well, the MAC address is a little different because it's a different port, but we see that it's Fast Ethernet 046. If we do a show CDP neighbor, Fast Ethernet 46 is the breakout switch, that 2924. So as you can tell, by default, it works exactly as we predicted. The oldest switch on the network is the root bridge. We don't really want that because the oldest switch on the network is the oldest switch on the network. What happens when you finally retire that guy? You take it off the network and now Spanning Tree goes who knows where. Let's verify this over on this 2924. Since this is running an older iOS, it's more of a router iOS than a switch iOS, the actual command is show Spanning Tree brief. In this case, we see on VLAN 1, root ID is priority. There's it. It actually tells us this bridge is the root. So this bridge is the root for VLAN 1. And you can also verify that by making sure that the address that's here is the same address that's right down there. And of course they match because it tells you, I'm the root. I'm everything. You look down here and you'll notice that all of its ports are forwarding except the ones that don't have anything connected to them. We don't have any blocked ports for the trunks, and in this case VLAN 30, same thing, this bridge is the root, because it has the lowest MAC address, and therefore I'm the lowest MAC address, I win. So now we get down to the nuts and bolts of configuring Spanning Tree. We don't want this 2900 to be the root of Spanning Tree for all of these VLANs. So let's look at our VLAN database. Let's go back over to the 2960 and we'll do show VLAN. So we have VLAN 1, 30, 40, and 50. So we have 4 VLANs on this guy, as well as all of the FDDI and Token Ring and all the other VLANs that we don't really deal with. So let's say that the 2960 will be the root of Spanning Tree for VLANs 1 and 30, and the 2950 will be the root of Spanning Tree for 40 and 50. Now again, you do that to load balance over the trunk links. Again, we've got trunk links going between all of these switches here. If we just configured one switch as the root of Spanning Tree for all of the VLANs, then you'd never use those secondary trunks going to the other switch. So let's go in and configure 2960. So we go into config mode, and all of our commands are going to be done under the Spanning Tree keyword. So we'll do Spanning Tree, we hit question mark, and we can configure Ether Channel and Loop Guard and all the other nice things. We'll get to some of those other commands in the other videos. For now, we're just going to configure Spanning Tree VLAN. So we'll do Spanning Tree VLAN, and we can specify a VLAN range. In this case, we will do 1, 30. This way we only have to type the commands once. Hit question mark. And this is where we can change the parameters for the forwarding time, the hello time, max age. You saw all of those parameters when we did the show span tree. We can also manually set the priority if we wanted to do that. However, we can just say that we're going to make this guy the root. So we can just do Spanning Tree VLAN 1, 30 root, and we can say, do we want to be the primary root or the secondary root? Now in the background, all these commands are doing is automatically configuring the Spanning Tree priority for us. And you'll see that once we're done here. So we do Spanning Tree VLAN 130 root primary, because we want this guy to be the primary. And we can also set the diameter of the Spanning Tree. For really, really large switched networks with lots and lots of switches, you can configure multiple spanning trees. In this case, we've got 3 switches on the network, so there's no point in specifying the diameter. So we hit enter, Spanning Tree VLAN 130 root primary, and we'll also go and do spanning tree VLAN 40,50 root secondary, because we'll configure this guy as the secondary root. So that way, if the other switch that's the root for 40 and 50 ever goes down, it won't default back to that 2900. So we do root secondary, hit enter. And so let's see what that did to our spanning tree configurations. We do show spanning tree. And now this bridge is the root. You notice that the priority is 24,577, which is 2 steps lower than the default. You can only specify priorities in increments of 4096 because it is a 2-byte number. And so you'll notice for VLAN 1, all of our ports are designated. They're all forwarding. We don't have any that are blocked because we're the root bridge. By virtue of being the root bridge, all of our ports automatically forward all the time. Look down here for VLAN 30, we're the root 30. We're also the root for 40 because our priority is lower, 28,712, than the default. Now you'll notice it's not as low as the priority for the bridges that we want to be the root for, 24,606, for example. But since we are lower than this 2900, we're the root for that now. So we'll go on to the bottom down here. We'll pause and we'll pick up our spanning tree configuration in the next video.